Guys, can you even believe it? It's time for math notes again. So solving trig word problems part 2. All right, roller coaster problem. A portion of a roller coaster track is to be built in the shape of a sinusoid. You have been hired to calculate the lengths of the vertical timber supports to be used. Ooh, look at this beautiful picture. It's a very nice picture. I'm looking at that and I'm seeing a wave here. You seeing a wave? Because I'm seeing a wave. I'm seeing like a cosine wave right here. Now, that looks like half a one. Obviously, we'd have to go up that for the rest of it, right? So let's kind of talk about that. Let's talk about what's going on right here. So if this is a cosine wave, it's not reflected. Let's talk about where maybe its middle or whatnot is. So it looks like the lowest point is 3 under, right? And it looks like the highest it goes up, oh, it's 30 from here to here, so that's up to 27. Okay, so if that's 30, 15 plus -3, that will put our middle right here at 12, right? Yeah, okay, so we've got that. So like we said, this amplitude is 15. I'm loving it. Now, let's talk about the period here. So it looks like a half of one happens in 50, so a full one must happen in 100. And I'm going to kind of erase that, hoping that you can see that. So, the period, to me, looks like it is 100 meters long. Now, we have to remember that the period is also equal to, and I like radians, 2 pi over b. So this is 100b equals 2 pi. So my b value is going to be pi over 50. So I'm figuring some things out here. Yeah, let's get to it from here. We got the highest point, we got the lowest point, we got everything we need here. What's it going to ask us on this next thing? The high and low points in the track are separated by 50 meters horizontally and 30 meters vertically. I mean, I saw that in the picture. The low point is 3 meters below the ground. Saw that in the picture. Letting y be the number of meters the track is above ground and x be how many horizontally from the high point. Write a particular equation expressing y in terms of x. Okay, so that was a fancy way of saying write your equation, use y's and x's. So our amplitude s is a regular right side up cosine curve, like if I keep going, you know. So that is 15 is our amplitude, cosine. We found our frequency, which is pi over 50. Now, it told us what to use. It said use x, so I'm going to use x. I started at 0, so no phase shift. Don't need to do nothing about that. And then the middle there is 12 we talked about. I think I need to scooch it over for you. There we go. It's 12. So there is our equation. How long, let me scooch this down. Come on, screen. There we go. How long is the vertical timber at the high point? Okay, so when x equals, I don't even think we need to do a lot of math here, guys. When it's at the high point, we're at 0 here. So you could plug in 0 into this equation right here and hit enter and find out what your answer is. But let's be real. How high is this timber? Well, it goes up to 27. So 27. So you can either say x equals 0, or you can look at the picture, but regardless, you're going to get 27 meters. Okay? On the next part here, it says, how long is the vertical timber at x equals 4? Now, on this one, I don't know. I can't look at the graph and tell, probably. No, I really can't. So you're going to pop this into the calculator. So y equals 15 cosine. Now, I use radians. So radian mode. We're going to pop that into the calculator, and I will tell you right now, when you do this, it's 26.5287. I kind of went all out with the digits there. Meters, okay? That's going to be your answer. At what horizontal distance, so that means x, will the roller coaster have a vertical height of 20? So vertical is up, down. So here's kind of what I would do with this. I would make this my y sub 2, and I would make that equation my y sub 1, and I would pop it into the calculator. Now, I would pause this if I were you. I'm going to pop it into my calculator, and I'm going to make sure I'm in radian mode. And I'm a big dork because I pointed to this equation here, and that's not the equation we want for y sub 1. It's this one up here in part A. So I popped it into there. You see it? There it is. I made sure my mode is in radians. It's glorious in every single way. we're going to look at this graph right here, and clearly the window is not going to work, right? So we definitely want to look up high, at least at 20, so let's change our window here. Definitely want to change my y-max. I'll use 25. Let's see what's going on now that I did that. I'm not really seeing a whole lot of things here. Alright, so I need to look a little further over to the right, and I will change my window to be even more to that. Okay, so let's say like that's 25, and let's say this is 40. Let's see how that's looking. Oh, looky there. There it is. There's the roller. Oh, there it is. So we want to find this intersection point. So second, calc, intersect. I'm just going to say enter, 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 because it's the only intersection on the screen. And that is our answer. It's this, comma 20. So this means it's 16.047 meters. All right, that's how I find it. So there you go. That concludes today's amazing math lesson.